So in this lesson, I'm going to go over the concept of scientific notation and standard notation. Now, scientific notation is simply a way of taking a very large number or a very small number and making it more manageable. So instead of me trying to go over a definition further, I want to show you a number of examples. This number here in this first example is 30 trillion. Now that represents the number of cells you have in your body. That is a lot of zeros to deal with. That is 13 zeros, and I really don't, when I'm grading something or when I'm looking at something, I don't really want to have to count the zeros to understand the significance of it. And so that's why we can take this number, which is in standard notation, and we often are going to want to convert it into scientific notation. Now the way that we do that is we're going to take this number and we're going to move the decimal, which is implied to be right here if you don't see it, and we're going to move it until this number becomes between 1 and 10. You can only have one digit, so it has to be equal to, or larger than 1, and it's got to be less than 10. So I'm going to move my decimal, and I'm going to count as I go. So I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. I need to keep going. 10, 11, 12, 13. So I moved it 13 places. Now I have a number between 1 and 10, and it's 3. Okay? And I moved it 13 places. So I'm going to multiply it by 10 to a power of 13. Now, where students struggle the most is figuring out if this should be a positive 13 or a negative 13. Keep in mind I took a very large number and I made it smaller. Now these two numbers need to be the same. Standard and scientific notation are the same number. So I need to somehow represent the fact that I took a really big number and made it smaller by multiplying by a positive power of 10. So in this case, it's going to be positive 13. If I wrote negative 13, then that would mean that the number in standard notation is actually supposed to be smaller than 3. But in this case, it's supposed to be larger. Now, looking at these two numbers, 3 times 10 to the 13th is a much more manageable number. This is scientific notation. This is standard notation, but they are the same number. Let's look at another example. Here I've got 0.000001. This is a very small number. This represents the size of a cell, the diameter of a cell in meters. Okay? So again, I don't want to have to count all my zeros. So what I'm going to do is I'm going to take the decimal, which I see, and I'm going to move it so that the number I write in front, to call my coefficient, is going to be between 1 and 10. And remember, it's got to be less than 10 itself. So I'm going to move this 1, 2, 3, 4, 5, 6. So I moved it 6 places, so this becomes 1 times 10. Now keep in mind, in this problem, I took a very small number and I made it larger. I took 0.000001 and I made it equal to 1. So since these numbers need to be the same, regardless if you're in standard or scientific notation, I need to represent the fact that I made a small number bigger by raising my 10 to the power of negative 6. If it were positive 6, that would mean that the actual number in standard notation is much larger than 1, but it's not. It's smaller than 1. Okay, let's look at another example. I've got 24,512.32. Now, I need to move my decimal so that the number's between 1 and 10. So I'm going to move it over 1, 2, 3, 4 places. So I'm going to write out this whole number, 2.4512.32. I can't drop any digits. Okay? And I'm going to multiply that by a power of 10. And I moved it over, just a reminder, 1, 2, 3, 4 places. So I have got to figure out, is it a positive 4 or negative 4 power that I'm going to raise it to? Well, this is a larger number and I made it smaller, so I need to represent the fact that this should get bigger if I put it into standard notation. So since I want to make it bigger to put it back into standard notation, this is going to be positive 4. Let's look at another example, 0.023. I'm going to move my decimal here 1, 2 places. Now this is between 1 and 10, so it becomes 2.3. I know I moved it 2 places. Okay. I took a small number, I made it larger, so then my power of 10 is going to be negative to represent the fact that this 2.3, to put it back into standard notation, is going to have to be made smaller. And it's made smaller by multiplying by a power of 10 that is negative. Let's look at another example. Here, if you notice, all of a sudden, instead of being given a number in standard notation, I'm now given a number in scientific notation. So I'm going to rewrite the 4.32 right here. Okay. Keep in mind, when I look at my power of 10, it's 10 to the positive 8, which means this 10 to the 8th is going to make this number larger. Okay? So to make it larger, I'm going to move my decimal to the right to make this number larger. If it were negative, it would make my number smaller and I would move to the left. So I need to move 8 places. So I'm going to move 1, 2. Okay? Now I need to move 6 more places. 3, 4, 5, 6, 7, 8. Now each of these spaces is going to be held by a 0. Okay, so if I were to write this number in standard notation, that would be a comma, that would be a comma, so this number would be 432 million. So 1, 2, 3, and another 1, 2, 3. Okay, so what I've written right here, this is standard notation, this is scientific notation. Okay, let's try one more example. Here, 1.23, I'm going to rewrite this. Now notice my power of 10 is to the negative 7th, which means this is going to make my 1.23 a smaller number, which means I'm going to move, instead of to the right like I did in the previous problem, I'm going to move to the left. So let's do that. I'm going to move it 7 places to the left to make it a smaller number. 1, 2, 3, 4, 5, 6, 7. And so my decimal is going to go right there, and then I'm going to fill in all of these zeros. So 6 zeros in front. Okay, so my number is 0.0000000123. That's standard notation. 1.23 times 10 to the negative 7th is scientific notation. So just as a quick reminder, when you're going from scientific to standard notation, a positive exponent, right, 10 to the 8th, will make the number larger, so you'll move to the right, your decimal to the right. If it's a negative exponent, it'll make your number smaller, so you'll move your decimal to the left. That same concept applies when you're taking a number in standard notation, so these 4 examples here, and putting it into scientific. Notice here, if I wanted to go back and check myself, 3 times 10 to the 13th, the 10 to the 13th makes the number larger, so I'll be moving to the right, which, if I did move to the right 13 places, would give me this large number. A negative exponent makes the number smaller, so you would move the decimal to the left, and that's exactly what I did. You would move it to the left 6 places. So these numbers, keep in mind, standard and scientific notation are interchangeable. They're the same number. So if you get this answer in class, and I tell you this answer, please don't say, is that the same answer? Because they are. They're the exact same number. Scientific notation just takes a very small or a very large number, and it makes it much more manageable.